Lesson 2, investigating the speed of water ripples. So this is the second of these lessons looking at the wave experiments. In the previous lesson you looked at planning this experiment. This is one that you did in class. And in this lesson we're looking at how do we analyze the results and have a think about whether those results seem to be reasonable or not. The first thing you should do is you're looking at this plan for the experiment. This is the plan that comes from the required practical handbook as published by the exam board. And there's a number of things that are important for you to note if a question comes up about planning the experiment. The first thing you have to remember is what some of these things are called. This tank, where we've got the water that we show the waves on, this is known as a ripple tank. So this word is important to remember. The term for this is called a ripple tank. And an easy one to forget about is we measure the distances with something called a meter rule or a meter ruler. Okay, so it shows the diagram where we have the ripple tank with a lamp above it, and underneath we have a white card where the ripples are going to be projected onto the card. Then on the next page it gives some instructions, and again, if you are asked this question in an exam, you need to try and replicate these instructions. So it says to put in a small amount of water into the tank up to a depth of about 1/2 centimeter. Adjust the height of the rod so it just touches the surface of the water. Switch on the lamp and the motor, and then you adjust the speed of the motor to produce low frequency water waves. It says adjust the height of the lamp so the pattern of waves can be seen clearly on the other side. And then place a meter ruler. So it's important that you use that term for the ruler, a meter ruler, at right angles. And at right angles is important. If the ruler is placed at any other angle, so if the ruler was placed so the water ripples are like this and the ruler is like this, clearly the readings we would get would be incorrect. So we need to be sure that we've said that we need to place the meter ruler at right angles. So it's not like this. It is in fact like this, as we would expect. So here are my water ripples, and my ruler is at 90 degrees to the water ripples. Okay, and it then gives some instructions for how to measure the wavelength and the frequency. At the bottom of the page here, we're given the results, and we're told that the frequency was measured in this case was 4.545 hertz, and the wavelength 0.025 meters. And it asks us to calculate the wave speed, use all 4 steps, and complete the table. So to do that, turn the page over. I've got step 1, and step 1 is always to write down the numbers that we've been told. So we've been told that the frequency is equal to 4.545 hertz. The wavelength is 0.025 meters, and we're looking for the wave speed. Step 2, we write the equation, which is known as the wave equation, which is that speed is equal to frequency times wavelength, which gives us speed is equal to 4.545 multiplied by 0.025. And then we take out a calculator, do the calculation, and we get an answer of 0.113625. Okay, so I'm going to write that answer as the wave speed is 0.114 meters per second. And what I'd like you to think about is, why did I round the answer? Why didn't I write it as 0.113625? Why did I round it to 0.114? Okay, so we can now put our answer in here, 0.114, into our table. So what's the result? The result is the ripples are moving at a speed of 0.114 meters per second. Next, you need to say, is this a reasonable answer for ripples on water? What this means is you need to think about, does this seem like a speed that is what we would expect for water ripples? And we could answer into this, since walking speed is 1 meter per second, this is a reasonable answer. That walking speed is something that you have to know. But what this question is really asking is, does this seem a reasonable number, comparing it to something that we know, which is the speed for walking. And then we have suggest another method for calculating the wave speed, this time using wave speed equals distance traveled over time taken. So what we could do here is, we're going to start again by saying, assuming that the rest of the method is set up as before, we say place a meter ruler at right angles to the waves shown on the card. Measure the distance from one end of the card to the other. Measure the time taken for one wave to travel from one end of the card to the other using a stop clock. Yep. We can say to repeat for several waves and get average time. Use the equation above to calculate the wave speed. Okay, you could also add in there that given a smartphone, you can obviously film the waves moving. You can slow it down so you can get a much more accurate answer. The last question then says, evaluate the experiment. Identify possible sources of random and systematic error and suggest how to deal with these. Okay, so random error is where we have our answer is close or around the actual number, but it could be sometimes too large and sometimes too small because of various things that we can't control. So, for example, it could be that in one time when a person was doing the measurement of time, they were a little bit quicker or a little bit slower when they started or stopped the timer. It might be that we've made some slight error when we're reading the numbers from the ruler, a slight measurement error. A systematic error is different. A systematic error happens when every time we take a measurement, it's wrong by the same amount every time. And this would happen, for example, if there was a problem with our stop clock and instead of starting at 0 each time, we were starting at 1 second each time, then all our times would have a 1 second error, a systematic error. So we need to identify some possible sources of these and how we might deal with them. So under random error, we might have there may be a random error measuring the time using a stop clock. And one way to deal with this is due to human reaction time. And there's a number of ways we can deal with this. This can be reduced by making the measurement several times and taking an average, which is what we suggested doing previously when we were talking about measuring the time taken for a wave to travel from one end of the card to the other. The second type of error is the systematic error. There may be a systematic error if the stop clock doesn't start from 0, or if the ruler is not aligned properly with the card. So we either have to start the measurement from 0 or remove systematic error from our results. So if we have a systematic error where, for example, each time we measure the time, if we are adding on a second because the stop clock was starting from 1 second rather than starting from 0, we can deal with that either by subtracting 1 second from each of our measurements, or before we do the experiment, we make sure that we check that all the equipment is reset to 0 and the ruler is lined up properly at 90 degrees to the waves with its 0 lined up with one end of the card. So those are two types of error that we can get in an experiment and how we deal with them.